The next part of Unit 1 we're going to talk about is simplifying expressions with exponents. So initially we're going to look at applying exponent properties involving products. The first property is the product of powers property. If you multiply powers having the same base, you add the exponents. So I'm going to give you a generic example. A to the x times a to the y is a to the x plus y power. So looking at this first example, this property tells us that it's okay to just add the exponents. I want to show you why, if you haven't seen it already. 7 to the third is 7 times 7 times 7. And 7 to the fifth is 7 times 7 times 7 times 7 times 7. So that's the same thing as count it all up. It's 7 to the 8th. I could have shown 7 to the third times 7 to the 5th is the same thing as 7 to the whatever 3 plus 5 is. That would be the quicker way to go. Try the next 3, call them 1, 2, and 3, and unpause the video when you're ready to move on. 9 with no exponent is really 9 to the first. So it's 9 to the first times 9 to the 8th times 9 to the second. If I add the exponents up, I get 9 to the 11th. Here, again, -5 with no exponent is really -5 to the first. Here I have -5 to the 6th. So I get -5 to the 7th power. If I don't know what the base is, but it's the same base, it doesn't matter. This is like saying a times a times a times a, and then times a times a times a. It's really just adding the 4 plus the 3, because there's 4 a's and there's 3 more, so there's a to the 7th. There's also the power of a power property. To find a power of a power, you multiply the exponents. So if I have a to the m raised to the nth power, my answer is going to be a to the m times n. So here's an example to show you why that happens. If I have 2 to the 5th to the 3rd, my base is 2 to the 5th. So I'm going to repeat 2 to the 5th 3 times. I can use the product of powers property to then add up the exponents. But adding something 3 times is the same thing as multiplying by 3. So I get 2 to the 15th here. Try the next 3. Again, 1, 2, and 3. And click continue when you're ready. -6 squared to the 5th power is saying -6 squared 5 times. This is where I can do it nicely on the computer. -6 quantity squared is this. I can, where's the button? Clone it. I can have 2. So there's 2 of them, 3 of them, 4, 5. You would not want to write all of that out. So the power of a power property helps us, instead of writing all of that out, I can say 2 times 5 is 10. If you double check, there are 10 of them there. So it's in parentheses -6 to the 10th power. X squared to the 4th. It's like saying x squared times x squared times x squared times x squared. I can add up those exponents and say, oh, that's x to the 8th. I could have just said 2 times 4 gives me 8. This last one, the base is this whole expression, y plus 2. I plus 2 to raise to the 6th and then raise to the 2nd. 6 times 2 is 12. So I'm going to have y plus 2 to the 12th, and that's as simple as it can get. There's also the power of a product property, which you've kind of been using some of the time. If you're finding the power of a product, you find the power of each factor and multiply. So if I have AB to the m power, it's the same thing as saying A to the m times B to the m. Unless you're told to write your answer using exponents, when they say simplify an expression, you need numerical values evaluated and written in simplest form. Here, we need to simplify the following expressions. On the previous page, it just asked for to write it as a power. And write your answer using exponents. 2 times 3 to the 5th is the same as 2 times 3 times itself 5 times. 2 times 3, 2 times 3, 2 times 3, 2 times 3. That's 5 times. Since multiplication is commutative, I could do the 2 times 2 times 2 times 2, 2 to the 5th first, and 3 times 3 times 3 times 3 times 3, 3 to the 5th second. 2 to the 5th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And 3 to the 5th, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. At this point, you might have wanted a calculator for earlier, but at this point, I can use a calculator to do that. 32 times 243. 7,776 would be my final answer. Try the next three and see how you do. 9xy quantity squared means 9xy times 9xy. I can do 9 squared, x squared, and y squared. This is not fully simplified because I know what 9 squared is. I get 81 x squared y squared. That's my final answer. There's nothing more I can do. Negative 4k quantity squared. I can do negative 4 squared times k squared. Negative 4 times negative 4 is positive 16, and I don't know what k squared is because I don't know what it is. It's just a variable, so that's where I stop. The last one was a little bit different. This is negative 4k quantity squared. So whatever I do, I'm doing 4 squared times k squared, and then making it negative. So this one gives me negative 16k squared. Last little bit here. Simplify these, and then continue to see the answers. I'm going to first simplify this part. 2 times x to the third squared, quantity squared, is 2 squared times x to the third squared. And I also still have that times x to the fourth. I know 2 squared is 4. X to the third to the second power. When you raise a power to a power, you multiply the exponents. That's 4 to the sixth. I have x to the sixth times x to the fourth. I can add those exponents. I get 4x to the 10th. 5 times this. I'm going to have 5 times 5 to the fourth times x to the 8th. I can actually simplify this too. There's always an imaginary 1. We don't write it. So I could say, oh, 5 to the first times 5 to the fourth is 5 to the 5th. I still don't know x to the 8th. Here comes the trusty calculator again. 5 to the 5th power times 5 times 5 times 5. 3,125. X to the 8th. Negative 10n squared times the quantity negative 4n to the third. Ooh. If I square this, I got negative 10 squared times n squared. If I cube this, I've got negative 4 to the third times n to the third to the third. That's messy. Negative 10 squared is 100. I'm going to leave the n squared alone. I'm going to do negative 4 to the third. A negative times a negative is positive, so I get negative Negative 4 times negative 4 is 16. And 16 times negative 4 is negative 64. This is all times. N to the third is n to the 9th. Now I need to multiply the things that can go together. N squared and n to the 9th will give me n to the 11th power. And negative 64 times 100 is negative 6400. So negative 6400 n to the 11th power. Last example. We're not going to have to worry about squaring anything or cubing anything numerically, because there's no numbers here, just letters with exponents. I'm going to deal with this part. I know I have that negative sign out front. Inside I have negative x to the 5th, because I multiply the exponent of 1 times 5. I have y, it was y squared to the 5th, so it's y to the 10th. Z to the 3rd to the 5th is z to the 15th. Take a little break there. The next one, I'm raising this to the 2nd power. I have x to the 4th squared, so that's x to the 8th, y squared, z squared. Since it's all multiplied, I don't really need the parentheses. I'm going to go down here. I have negative x to the 5th gives me, well, it's like negative 1 times x to the 5th. So that negative sign is still there. This gives me negative x to the 5th, y to the 10th. Because if I raise negative 1 to the 5th and x to the 5th, I get negative x to the 5th. So I've got all of these together. Oops, sorry, z to the 15th, x to the 8th, y squared, z squared. So I can cancel out the negative times negative because that makes this whole thing positive. X to the 5th times x to the 8th is x to the 13th. Y to the 10th times y squared is y to the 12th. Z to the 15th times z squared is z to the 17th. That's a whole lot of letters.